Probably for future studies, you could even visit, if you go to Strathmore, I don't know if they've been there.
Yes, they have their own
Everywhere
PV.
is just panels and panels and panels. They are energy sufficient, and they also sell it to the grid.
It's true.
So a low-hanging fruit could be that wind and the panel. I mean the solar issues. Yeah. Thank you.
Thank you. Yeah.
Yes, thank you. I appreciate the project you have there. It's a nice one. My question is that can the project work without the wind turbine, or it can work with the solar and with the absenteeism of the wind turbine?
Oh yes, it can. Actually, for me, the data that I chose, I think I had already said, I chose the system that gave me the least amount in the net present cost. But if in my paper, actually, I have the whole configuration. Actually, there are times whereby it can also just be running on solar and the batteries alone. There's a times whereby it can be running on solar and biomass alone, and then it gives you a different cost of the system.
Okay.
Yeah.
According to the numbers per year, did you recommend or make the exception about the maintenance costs in case of any breakage or any non-functionalities parts of the project?
Okay, for the total cost, actually for the cost of my system, I looked at the capital cost, the maintenance cost, and also the replacement cost of the system. Yeah, so I factored them all in. Yeah.
Okay, thank you.
Yeah, because also for the batteries, actually, they cannot run throughout the 25 years. You have to keep on changing them after some number of years. Yeah.
In terms of this biomass, you are converting it to electricity from gas, or is it initially biogas and then converting to?
No, there's actually a gadget that converts, actually it's a generator, just the same way that you can feed in diesel to a generator. So this one actually, yeah.
A gas engine. So this is simulated,
yeah,
but not actual equipment and
no.
construction of this. That we'll like to see how then the actual construction will relate to the simulated results. And it's good you have said, when now we come to actual mambo kwa ground, then we will see how it will relate to your results from the simulated. And if there are any errors, then you will be able to rectify. But these various sources are generating independently, and then you match this power into one. Are you doing changeovers, or how is these different powers simulated?
We normally have a converter as in my system. Actually, it's the one that does all the changes. Yeah, but anyway, even in the country currently, yeah, how we generate power, it's from different sources, and then you supply it to actually your it's called what? Your subsystems, and then they are distributed to the other countries. But for different sources, so the main sources is the type of voltage that it produces. For example, for solar, it produces DC power. For the batteries, it's also DC. For the others, for wind, biomass, and hydro, it's AC. So those ones, they can run in the same bus, but for the others, you need first to convert it to AC for it to run as it should. Yeah.
Yeah, thank you, Fiona, for that presentation. Actually, it's a good proposal if implemented. I was just wondering on how you will implement or generate hydropower, because looking around, which rivers have you identified, or sites where this type of power can be produced?
Actually, that is true. Yeah, so for hydro, the river that I actually use, the one that is closest, is the River Cavita. So that one actually, for hydro, it has the most cost because even the cost of first generating and then distributing to this particular part, it's actually high. In other simulation platforms that we have used, apart from Homer, for hydro, actually it was not recommending hydro. For this particular system, as I said, it gave me the 5.5 because of the system constraints that it has. It cannot actually suggest a lesser value than 5.5. Yeah, but in the same configuration, there are others that actually, other readings that was not actually recommending the use of hydro because of the cost of the system. If it was higher than that, the cost is very high. If you needed actually to generate the power from River Cathita, transmit it to this particular region, it's very expensive.
So in that case, must we have it in our list? Can we just do with, for example, solar, maybe wind and biomass? Then we stop at that. Must we include all the rest, even though we know that they are not feasible in this case?
No, it's not a must, because once I give all the configurations that we have, it is best, number one, because I was not even looking at convenience, but when you actually come to implement on the project, it's good to ask all the questions, and then you can see what you can do away with in this particular system.
Yeah, I had a question also on the same. I don't know how is the stability of the grid based on these sources of power.
Okay, when we talk about stability, according to research, for me, I'm talking in terms of electrical engineering perspective. So when you're looking at stability, is the loads that we have, our demands must be met, and our voltage regulation is good. Now, one of the recommendations that is normally given from other researchers, developing your own mini grid or having DGs, distributed generations. It's one of the ways of increasing stability for your system. So if you have a hydro system that is a microgrid, that is actually autonomous, it's not actually supplied by the grid, and you have designed it to meet all your demands, then that is a stable system because you are supplying all your demands and also your voltage regulation for the system is okay.
Okay, probably I would have put it differently this way.
Okay.
Most of the renewable energy like solar and wind depend on or are affected by other environmental factors. Keeping that in mind, it means at a time probably you are at peak, and probably your peak point was in the evening, and solar will be down, probably wind will be off. I don't know how would you manage to meet the demand at that point. I don't know if you considered a criteria or multi-criteria analysis on how you can select some of these sources of power for your model, because if you are ranking hydro to be the lowest and you are giving solar the highest, and I don't see diesel generator which can be a most reliable energy source in case all others are down. So I don't know how best you should have done that. And probably lastly, if the model has anywhere you can do any validation and see how best it can work.
Thank you so much. Okay, well understood. Okay, so for the first question on the, I think that is something that I had mentioned on the intermittency of solar and wind, especially at night and during periods of low wind speeds. So for my system, number one, for this particular research actually, I was looking at renewable energy sources whereby my renewable energy penetration is 100. So I was not considering diesel, yeah, I didn't actually consider diesel for this particular system, but for future analysis, I can still include diesel to look at the total cost of my system. But currently, if you look at this particular graph, actually that shows on the demand that I had calculated, yeah, so during you will notice that solar, it will produce energy at some point, and then you have the blue line, actually, that is my demand. During those seasons whereby you don't have enough, we had biomass, and also we had batteries that are also in my system that I used that to supplement. So that is the reason actually why I chose a hybrid system. It's to actually reduce on the issues of when we don't have this resource, what happens. So that is why I combined different sources to see if it can be able to supply the power of my system. So for the diesel engine, so for me, I was just considering hybrid renewable energy systems. Yeah, for diesel, it's not renewable, but still, I can be able to add it to my system to see the size and the cost of having diesel generators included to my system.
Yes, yes.
Oh.
It's not even a question, eh? There used to be a school called School of IT and Engineering. That time you didn't come around. So there's a project, there are a lot of equipment which are bought. One of them is, there's a wind. I don't know whether you saw it. It's in the workshop there. Wind. I think Akeranjero can tell you.
Yeah,
Yes, it's there. Wind, it's a wind turbine, eh? And then there is also some panels. So probably with that too, you could think of just simulating that. I mean, it's a really big, I mean, there are panels, there's that wind thing, and also these days, the panels have been zero rated. So 540, 50 watt, you can buy them now for around 11K or even less, eh? So with those two, you can basically simulate. I don't know who will finance that, but yeah, so that you can upgrade it. Thank you.
Thank you so much. Yeah.
Yeah, thank you, Fiona. Yeah, we have a lot of interest in your research. That is why it has generated a lot of questions. I want us now to close our session. Mine is to appreciate you for your patience. We have been seated here from 3 up to now, and we have had insight into various types of research, starting from the keynote speaker all the way to what we have heard now by Fiona. So with that, we have come to the end of our today's presentation. Tomorrow, we'll still continue here. From what time? From 9 a.m., we'll be here, both engineering and ICT. We have a number of presentations to be done tomorrow from morning all the way to 5 in the evening. So therefore, we still need you here as the audience, because we cannot do the presentations without the audience. Is there anything else? Okay, so we can close for today. Have a great evening. Thank you. Thank you so much for your participation.